So now we know how to simplify, we know how to multiply, and we will have to also divide. So dividing radicals is not any more difficult. There's just multiple ways that it can be done, which is kind of confusing. Okay, so for example, this guy right here, we could do all of the division process, or we could say, oh, you know what, look, 20 is divisible by 5, right? 20 divided by 5 is 4, so that gives me the square root of 4. If the numbers are both under the radical, then you can just divide, if they divide nicely, and if it will help you, okay? This helps us because the square root of 4 is 2, and we're done, okay? Now, the process of dividing, unfortunately, is not always that quick and easy, and so I'm going to use the same problem to show you how we actually do it. The problem is that, or the rule is, or whatever, is that you can't have a radical on the bottom, okay? So if you left this as an answer to something, it would be wrong because you can't have a radical on the bottom. That's a no-no, okay? It's, I can't even think of an equivalent. You can't have a radical on the bottom as part of your answer. So we need to get rid of it. And it's this fancy, not that hard, but fancy process we call rationalizing the denominator, okay? The denominator being the bottom, right? Rationalize meaning making it a whole number, okay? So what we do is we multiply by whatever that radical is on the bottom. But we have to do it on the top and the bottom. It's kind of like balancing an equation. What you do to one side, you got to do the other. In this case, what you do to the bottom, you have to do to the top, okay? And then all the other stuff we've learned comes in handy. So remember, we're multiplying. So 20 times 5 is 100. So that gives us square root of 100. Don't forget to take the square root, the radical, with you, okay? Now, we do this on the bottom because when we multiply a radical times a radical, or the same radicand, right? This gives us this, which is really just this, okay? So you don't have to go through that whole process. Just know that when you multiply a radical times itself, you get just the radicand, or the whole number, which is the whole point. We have rationalized the denominator. We made the denominator into a whole number, okay? Now, you can't just change it to a 5 and not do this part on the top, okay? You got to do that part. So now we have the square root of 100 over 5, okay? And sometimes you can simplify that guy on top, sometimes you can't. Sometimes you can do more. It just depends on the problem and the numbers, right? So in this case, square root of 100 is 10 times 5, over 5. Is 2, which is what we got when we did it the easy way before, right? Okay, so let's look at this guy. I'm going to erase all of this. So if you need to, pause and write all that down. But I'm going to erase this so that I can use the space. So we've got 3 radical 20 over 4 radical 4. Okay, so if we were in class, I would say, do you see anything that you could do besides having to rationalize the denominator? And some of you might say, yes, 20 is divisible by 4, okay? But I want to practice rationalizing the denominator. So you could do it that way if you wanted, but I'm going to rationalize the denominator because I want to practice that with you. So you don't have to multiply by the 4. You only have to multiply by whatever the radical is. And it will probably, most cases, make your life easier if all you do is whatever the radical is. So we're going to multiply the top and the bottom by radical 4. So that's going to give us 3 radical 100. Nope, I lied. I could do math. 80 over 4 times, that becomes 4, right? So we got 16. So this becomes 4 times 4, because radical 4 times radical 4 is 4, right? But we had that 4. So that's where I got the 16. Go back and listen to that again if you need to. So this is all nice and pretty, okay? 3 and 16 are not divisible, so we can't do anything with that. If you could, like say this was a 4, then you could divide that, okay? But it's not, so we can't. But we can simplify that radical 80, okay? You might have already done simplified radical 80 by this time 20 times, so you might know what that is because you've already had to do that several times on assignments. But we're going to do it again now partly to refresh our memory on how to simplify. So we've got 80. I'm going to do 8 times 10 because that's the first thing my head thought of. And that's 2 times 4 and 2 times 5. And that's 2 times 2. And everything else is prime. So we've got 4 2s. We've got a pair of 2s, and that leftover 5. So 2 times 2 is 4, radical 5. Right, which is the same as our radical 80, which means we've got 3 times 4 times, whoops, not times radical 80, times radical 5, sorry, over 16, right? That 3 and then that 4 radical 5, yes, and then the 16. Okay, that's a lot of arrows. I am so sorry. I go a little nuts. Okay, now, so that makes this 12 radical 5 over 16. If you were to leave it there, I would be okay with that, but you can reduce that fraction, okay? So 4 goes into 12 and 16, so this is really 3 radical 5 over 4. 12 over 16 is really 3/4. So that's really your most simplified, okay? Which, if we get here, it means you know the process, yay. If you get here, it means you know your basic math skills. So that's good, okay? Let's do some more. Again, if you didn't write all that down, pause and write it down, or maybe go back and listen again and write it down. So here we have 5 radical 15 over radical 16. So the 15 and the 16, there's nothing you can do there. You can't go ahead and divide into it or whatever. So we have to rationalize the denominator, which means we have to multiply top and bottom by whatever that radical is on the bottom. So that gives us 5 radical, I don't know, what is 15 times 16? 240. And then 16 on the bottom. Because remember, when you multiply a radical times itself, you get just the radicand, or the number inside. So that looks nice, but we do have to simplify the 240. So what goes into 240? Well, let's use 15 and 16 because that's what we just used to get it, right? So 3 times 5 and 4 times 4. Now, some of you will see, well, that's a pair. Can I leave that there instead of going 2 times 2 and 2 times 2? You sure can. So if you have a pair of 4s like that, it means that a 4 is going to go outside. And then you have the 3 and the 5 left over, so 15 is going to go inside. Okay. If you didn't recognize this, it's okay. You would have recognized this and done 2 times 2 to get your 4, right? So there's 2 different ways to look at that. Except don't forget your 5 and your 16 as part of your actual problem, right? I tend to do that too, I understand. So this is really 20 radical 15 over 16, except that 20 over 16 can be reduced. 4 goes into both, so it's 5, that's not very dark. 5 radical 15 over 4 is your actual final answer. Whew. Let's do one more. I'm going to erase all this, so pause if you need to write it all down. Okay, so some of you might say, hey, I can reduce 2 over 4 and I can reduce 15 over 12. Okay, you can at this point, or you can not. It's up to you. I'm going to reduce at this point just to kind of show the people who want to do that how to do that, okay? If you reduce first, it means you're going to be dealing with smaller numbers as you move on. You'll still have to I can talk. You'll still have to rationalize the denominator maybe, okay? But you won't have as big of numbers probably when you do that. It's up to you. So 2 over 4 is really 1 over 2. And 15 over 12, 3 goes into both of those. So that gives us radical 5 over radical 4. And in this case, it actually makes your life easier because radical 4 is 2. Oops. So this is really radical 5 over 2 times 2, or radical 5 over 4. I'm going to do it the other way, just to show you what the process would have been to do it the long way. Because some of you don't know your multiplication and your division and all of that stuff, and so you don't look at this and see that all of that can be reduced, etc. Okay, which is fine. So if you understood that, if you think you're good, you're done. I'm just going to do this one problem the other way, and then the video will be over. So up to you. I'm going to go back to my original colors. Okay, so if you don't do any of that reducing, it means you've got to rationalize the denominator, right? So multiply by that radical on the bottom. So that gives us 2, I don't know what's 15 times 12. Whoops, 15 times 12. 180, oops, 180 over 4 times 12, right? So what is radical 180? We need to simplify that. So 180, my head went to 18 and 10, so that's 9 and 2 and 2 and 5 and 3 and 3. So that gives me a pair of 3s and a pair of 2s and a leftover 5. So 3 times 2 is 6 radical 5. So that's what's in place of the 180. So that means it's 2 times 6 radical 5 over, I'm going to go ahead and do that math, 48. 2 times, so that's 12 radical 5, oops, 5 over 48, and this can be reduced, so that's 12 goes into both of those once, so that's radical 5. If you leave that 1 there, that's okay, over 4, which is what we got when we did it the other way too. So whichever works for you. Many of these problems will have more than one way to approach it. If you want to just rationalize a denominator every time to start, go right ahead. Okay? If you're like, I have become an expert at that and I think it's fun, do it. It works every time. But don't forget to make sure you get to the most reduced answer. Ask questions in class.